Okay, so today we are going to start second order derivative. Okay, so what do we understand by second order derivative? Let's try to understand first. Okay, so as we know that as y is equals to fx, if I differentiate this y with respect to x on both the sides, then I'll be getting dy by dx, which is equals to f dash of x. So this is our first order derivative. First order derivative means we'll have to differentiate just once. Okay, but if that function again, if this dy by dx, if I differentiate again with respect to x, then what will I get is d dx of dy by dx, which means we are differentiating dy by dx again with respect to x. And the same happens in the right hand side, d dx of f dash of x. So what will I get out here? I'll be getting a new thing now, and that new thing is d2y by dx square. If I differentiate dy by dx again with respect to x, then I'll be getting d2y by dx square, which is equals to f double dash of x. Now this f double dash of x, or d2y by dx square, is known as second order derivative. Okay, so how do I read this? We read this as d2y divided by dx square, d2y by dx square, which is equals to f double dash of x. This is our second order derivative. So whatever we are doing till now, it was first order derivative. Now that first order derivative, again it should be differentiated by x, then we get d2y by dx square. Okay, so now d2y by dx square, f double dash of x, y dash, y2, all this symbolizes the same thing. Okay, this means the second order derivative of the function y. dy by dx is the first order derivative of function y, and d2y by dx square is the second order derivative of function y. All the formulas are same, the u by v rule is same, the differentiation by substitution is same, so everything is same. You just have to differentiate it once again. Okay, so that's the only problem out here. So we are now moving to exercise. Okay, so we are moving into question number 1. That is, okay, first we have exercise 5.13, question number 1, part 4. Okay, so the question is differentiate or find the second order derivative of the following functions given out here. You need to find the second order derivative of this function y, which means we need to find the value for d2y by dx square. d2y by dx square. Very simple. First find dy by dx, again differentiate with respect to x, then we get d2y by dx square. Okay, so let's start differentiating. So differentiating both sides with respect to x, we get dy by dx, and this side d dx of x cube plus tan x. Okay, so therefore dy by dx is equals to differentiation of x cube 3x square, differentiation of tan x 6 square x. So keep it as equation number 1. So this is the value for dy by dx, but see, we need to find the value for d2y by dx square. So again differentiating with respect to x, I will be getting d dx both the side. Okay, differentiating both the side. So here will be d dx of 3x square plus 6 square x. Very simple. This now, what we have learned just now, d dx of dy by dx is nothing but d2y by dx square. The same thing out here also, d dx of dy by dx will be d2y by dx square, which is equals to differentiated term by term. 3 is a constant, differentiation of x square is 2x plus d dx of, now I don't have a direct formula, so sec x whole square. So therefore d2y by dx square is equals to 3 to the 6x plus, assume this as x, so 2x, and then differentiation of sec x is sec x into tan x. So the final answer, the value for d2y by dx square will be 6x plus 2 sec square x into tan x. So this is going to be the final answer for us. So I hope you people are clear with this, how to find the value for d2y by dx square, how to find the value for second order derivative. The very most important thing out here is you need to know how to differentiate it. The formulas has to be clear. Okay, and simply yes, that's it. Yes, you find the value for dy by dx. Again, differentiate it once with respect to x, then you'll get the value for d2y by dx square, which is a second order derivative. The same thing we have to repeat in all the questions given out here. Okay, so now I'll be selecting some few questions from here, which we are going to do. Okay, so in that way, I'm going to give you the whole idea. Okay, right. So this is the question given to us. Now I'm moving on to question number 6. So from question number 6 onwards, we need to do the question proving type of questions. Okay, if y is this, then prove that the left hand side equals to right hand side. So this type of questions we need to do from question number 6 onwards. Okay, so this is our question number 6. Let us go to the question once. Y is equals to cot x. Prove that d2y by dx square plus 2y into dy by dx equals to 0. So look at the left hand side properly. Okay, in the left hand side, what do we have? We have the second order derivative, as well as we have the first order derivative. We also have y. Okay, y is this given function. We'll find dy by dx. We'll again find d2y by dx square. We'll put in the left hand side and try to prove it as 0. Simple as that. Okay, so let us do. So dy by dx. So ddx of cot x. ddx of cot x is minus cos x square x. Okay, again differentiating. So again differentiating, we will be getting ddx of dy by dx, which is minus ddx of cosec x whole square. So therefore d2y by dx square is equals to minus differentiation of cosec x. So I have to assume it as x square, isn't it? So therefore 2 into cosec x, and then differentiation of cos x once again, differentiation of cosec x, which is minus cosec x into cot x. Okay, so d2y by dx square is equals to minus 2 cosec x is already there. Differentiation of cosec x is minus cosec x into cot x. Okay, so everywhere it's multiplication sign. So the value for d2y by dx square is equals to minus and minus plus 2 cosec square x into cot x is the value for second order derivative. This is the value for the first order derivative, and this is the value for the second order derivative. So let us see in the left hand side now, just substituting the values. Okay, so d2y by dx square plus 2y into dy by dx. Remember that we have to prove it as 0. Let's start putting the values. The value for d2y by dx square is 2 cos x square x into cot x, plus 2 is there. What is the value for y? The value for y is cot x. What was the value for dy by dx? Minus cos x square x. I hope you're getting the idea now. Cos x square x into cot x, plus and minus minus 2 cos x square x into cot x. So two equal terms, same terms with different signs, so easily they get cancel it out, and hence which is equals to 0. So which is our right hand side as well. So hence we are proved. Done with this. Okay, it's very easy. Differentiate once, differentiate again, find the value, put in the left hand side the respective values, simplify it, it's going to be 0. Almost all the questions are same. Okay, so yes, so this was our question number 6, part 1, to prove left hand side equals to right hand side. Okay, and then 6 part 2 will be your homework, a similar type of question. 7 part 1 and 8 part 1 also similar type of question. Just find the value for dy by dx, d2y by dx square, put in the left hand side, and then here done. Okay, any problem you can send me. In which question you're having problem, you can send me in my mail address. Okay, so now I move to question number 11. So in your question number 11, you can again see, read the question. Y is equals to tan inverse x. Prove that left hand side equals to right hand side. You can see out here second order derivative, you can see out here the first order derivative. It's very simple and easy. Let's find the value for dy by dx. We'll find the value for dy by dx, we'll find the value for d2y by dx square and dy by dx and put in the left hand side and finish the problem, okay? So dy by dx, I hope you know the formula for differentiation of tan inverse x, which is 1 by 1 plus x square, okay? Again differentiating, so again differentiating means d dx of dy by dx, and see this is also 1 plus x square whole to the power minus 1, okay? So therefore d dx of the same thing 1 plus x square whole to the power minus 1. The left hand side d2y by dx square, right hand side assume it as x, so minus 1 into 1 plus x square whole to the power minus 1, so minus 2, and into d dx of 1 plus x square. We are almost there now. So d2y by dx square minus, drop it down to denominator, the power will be positive. It is into 1 by 1 plus x square whole to the power 2. I hope you know the differentiation. 1 0 plus 2x. The 0 plus 2x is only 2x. So therefore finally we get the value for d2y by dx square, which is minus 2x by 1 plus x square whole to the power 2. This is the value for d2y by dx square. This is the value for dy by dx, any of this which you want to use, and then we'll solve the left hand side now. So LHS, simply putting the values. We already have 1 plus x square into d2y by dx square. Okay, so first let's write down the left hand side. 2x into dy by dx. Remember again here also we have to prove the value as 0. So 1 plus x square, the value for d2y by dx square minus 2x by 1 plus x square whole square plus 2x into dy by dx is this value. Dy by dx, the value is 1 by 1 plus x square into 1 by 1 plus x square, okay? So what we can do out here is we can cancel 1 plus x square and to the power 2. So 1 plus x square into the power 2 gets cancelled out. In the next page, let us see in the next page what do we have. So therefore, left hand side, we are still solving the left hand side, okay? So therefore, this and this gets cancelled out. This and the power gets cancelled out, by the way. And minus 2x by 1 plus x square plus 2x by 1 plus x square. So simple as that. Same terms with negative and positive gets easily cancelled out, so which is 0, which is also our right hand side. So hence we are done with this, okay, proved. So in the similar way you will also try question number 11 part 2. Your homework will be number 11 part 2. 11 part 2. Okay, so now homework will 11 part 2. I move to question number 12. And question number 12 is y is equals to sine log x. So y is equals to this. Y is equals to sine log x is the given function. So we have to prove this given thing, x square into d2y by dx square plus x dy by dx plus y equals to 0, which you can refer your book, okay? So yeah, the first step is the same step, yes, to find the value for dy by dx. So find dy by dx, sine log x. How will I differentiate? Assume log x as x. So sine x, differentiation of sine x is cos x, so cos log x into d dx of log x is 1 by x. So far I got the value for dy by dx as cos log x by x. You can either differentiate, find the value for d2y by dx square, or another method we can also do out here. I'm going to do cross multiplication, okay? So it's going to be a new thing for us. So we are doing cross multiplication, okay? We can also proceed with the previous method, finding d2y by dx square and putting in the left hand side, right hand side, okay? You'll get the proof. So I'm cross multiplying it. So x into dy by dx, which is equals to cos log x. And now we are taking the differentiation. So differentiating both sides. Here will be u into v rule. So x into d dx of dy by dx plus dy by dx into d dx of x. Okay. So x constant, differentiation of dy by dx constant, differentiation of x, and this side differentiation of cos x minus sine log x, and differentiation of log x is 1 by x. So we know this, and here we get x d2y by dx square plus it is 1 only dy by dx, which is equals to minus sine log x divided by x, and then finally I'll cross multiply with x again. So this is going to be out here. So if I cross multiply with x, because see, there's a bracket, isn't it? So if I cross multiply with x, x multiplies with the first term, x multiplies with the second term as well. So x into x, it will be x square d2y by dx square plus x into dx dy by dx is x dy by dx, which is equals to minus sine log x. Okay, the sine log x, and don't forget the value for sine log x is nothing but y. Y is equals to sine log x. Y is equals to sine log x. Here also I am getting minus sine log x, so which means it is y. So minus y. Bring it to the left hand side. It will be plus y. That is going to be your proof. Okay. So therefore x square into d2y by dx square plus x into dy by dx. See, in the last line we have got till here minus sine log x. This was the last line, isn't it? And the value for sine log x is nothing but y. So y, this is minus y, bring it to this side, it will be plus y. Okay, so x square d2y by dx square plus x dy by dx, and this is plus y, which is equals to 0, so which is our proof. So I hope you're clear with this. So this is how we do second order derivative.